we are going to problem solve using our methods of factoring, okay? So we're going to incorporate some word problems where we have, a polynomial equation that has x squared and it has an x term. So we have to solve by factoring, by turning one side into 0 and then solve by factoring. So let's say we have two consecutive odd integers, okay? And we know that the sum of their squares is 130. Okay, so I'm going to call these two consecutive odd integers. I'm going to call one of them x, and then the other one is just 2 more than that, right? 7, 9, 9 is 2 more than 7, etc. Okay, so I'm going to call one of them x, one of them x plus 2. I'm going to square both of those, so I'll have x squared and then x plus 2 squared. And I know that their sum, right, when I add them together, it should be 130. So we know the goal is to get one side equal to 0. So first I'm going to expand the x plus 2 squared into x squared plus 4x plus 4, and then I'll subtract 130 from both sides. So I get 2x squared plus 4x minus 126 is equal to 0. Okay, so now you know that if you're going to factor, I can't do it from here. I have to notice that everything is even, which means I can factor out a 2 out of every single term. So I'm going to factor out a 2, and then I have x squared plus 2x minus 63. Okay, I know that I'm going to get these two terms where I start each one with x, and I try to think of something that multiplies to negative 63, adds to 2, so one is positive, one is negative. I get positive 9 and negative 7. Okay, so I know I have two solutions for x, okay, and that's what makes those terms 0. So negative 9 makes the first one 0, 7 makes the second one 0. Okay, but negative 9 is just one of the integers, right? The other one is negative 7, and 7 is just one of the integers. The next odd integer is 9. And we're done with that one. So let's suppose there's a triangle with a height that is 7 meters. I should have just said bigger. Taller doesn't quite make sense. 7 meters bigger than the base. Okay, I don't necessarily need to draw this isosceles, so I'm going to draw it again, just so you know that it's kind of ambiguous what kind of triangle it is. All I know is that here's the height, and then here's the base down here, and that the height is equal to 7 more than the base. So it's 7 plus b. Okay, and I also know that the area of a triangle is equal to 1/2 base times height, if you recall. Okay, so what we're going to do is we're going to say that height is 7 plus b, b we're just going to keep as b, and then area is equal to 15, that's what's given in the problem, and that's 1/2 base times height. So I'll set 15 equal to 1/2 base times my height in terms of my base, so 7 plus b. And I'm going to solve for this. So the first thing I'm going to do is multiply both sides by 2 so that that 1/2 will go away, and I get 30 is equal to 7b plus b squared. I've distributed that b into the polynomial. If I rearrange this, I get b squared plus 7b minus 30 is equal to 0. Then I'm going to factor. So I get 1 positive, 1 negative, because they're multiplying to a negative. Bigger one is positive, so I get 10 and negative 3. Okay, and therefore the two things that make this equation 0, negative 10 and 3. But think about negative 10 as this for a second here. Negative 10 doesn't make sense because it's a base of a triangle. I can't have a negative base. So the base is going to be 3 meters, and the height, 7 more than that, is 10 meters. And I'm finished with that problem. Okay, Bob throws a ball to Jane. Jane is 40 feet above Bob, so Bob throws with an initial velocity of 56, okay? And then Jane is missing it on the way up, but catches it on the way down. Okay, I meant to say the way down. Correct that. It says the way down. I accidentally wrote the way up. Okay, so how long was the ball in the air? So I'm going to give you these two equations that, kind of guide motion. So we have the height of the ball, or the height of anything thrown upward, is going to be v naught times t. So v naught is just initial velocity times t minus 4.9 t squared. This is the equation you use when you use meters because gravitational acceleration is equal to 9.8. And then you would use the second equation on the bottom when you have feet, okay, because gravity is equal to 32 feet per second squared. So I'm going to use the second one because this problem involves feet. I'm going to draw it. So we have Bob down here. He's throwing the ball upward with an initial velocity. That's what that little 0 means, initial velocity, 56 meters or feet per second. Okay, and then Jane is up at the top of this balcony, right? And she's not going to catch it on the way up, but she's going to catch it on the way down. So she's going to miss it when it first passes her, but she's going to catch it as it comes back down. Okay, you'll understand why that detail is important later. Okay, and then this is the height she's at. I know that's equal to 40 feet. I know that this initial velocity is equal to 56 feet per second. So I'm using that second equation that I was given. These are also in your book, that it's equal to v naught times t minus 16t squared. I'm going to plug in my height. I'm going to plug in my initial velocity, and then I'm going to make one side equal to 0, one side of the equation equal to 0. I'm rearranging it so I have the t squared term first, and then the t, and then the no t. And then I'm going to factor out a negative 8 to begin, so that I get 2t squared minus 7t plus 5. Okay, now I can factor. I'm going to use my x method because I have a leading coefficient. So I get 2t squared times 5 is 10t squared, and then I drop down negative 7t, and I get that my two factors that would multiply to positive 10 add to negative 7 are negative 5 and negative 2. I'm putting the first and last terms of my polynomial, and then those two that I got from my x, and then I'm factoring out what I can from each box. If you need to go through this more slowly on your own, pause the video and come back to it. Just make sure that you're taking the correct numbers out of each. Okay, so I get my two factors, t minus 1 and 2t minus 5, and those are equal to 0. So the two values for t that make this 0 are 1 and 5 halves. Now let's think about what this means. The 1 second corresponds to if she had caught it on the way up, but she caught it on the way back down, which means I have to pick the time that's more. Okay, so 5 halves is the time that is more, right? Because it's gone past her and then fallen back down. So I get t is equal to 2.5 seconds. That's how long the ball is in the air. Have a great day and good luck on your homework.